So in 12.2, we're going to talk about an arithmetic sequence, and an arithmetic sequence can be defined recursively as a sub 1 is equal to a, and a sub n minus 1 is equal to d, or we could just say a sub 1 equals a and a sub n equals a sub n minus 1 equals d. But basically, this is the very technical way to think about it. Basically, what you can do is you can think about an arithmetic sequence as a linear. It almost takes on the form, or it does take on the form y equals mx plus b. So if you can ever write your sequence like this in this form, obviously it's not going to be y equals mx plus b, but if it has this shape to it, then it is an arithmetic sequence. And what an arithmetic sequence, basically the dead giveaway is, each term is changing in the sequence through addition or subtraction by the same number. So if you go from one term to the next and then to the next and then to the next, and it's always the same amount added or the same amount subtracted, it is an arithmetic sequence, okay? So that's kind of the dead giveaway for an arithmetic. So it's through addition. In 12.3, we're gonna talk about geometric, and in geometric, it changes from each term by multiplication. Whether it's multiplication by a whole number or a decimal or a fraction or something, it's multiplication. So arithmetic is like arithmetic, like addition or subtraction, and then geometric is a little fancier, kind of like multiplication. And in calculus 2, we really, spend a little bit of time, or we spend, quite a bit of time on geometric series, which come from a geometric sequence. So it'll be a big deal in calculus 2. You'll see it a little bit in calculus 1 with sequences and series when you're explaining like Riemann sums and stuff, but not too much. So, and again, it can be defined recursively, meaning that you can basically work backwards from the terms. You can define it from the terms. So we say that A is the first term. So A is going to be the first term in the sequence, and D is called the common difference. So if you know these two things, you're home free. You can build your arithmetic sequence. They follow a pattern where you have the first term, and then you take the first term plus the common difference. Then you take the first term plus 2 times the common difference. Then you take the first term plus 3 times the common difference. So each time the terms are changing by one more common difference. You're adding or subtracting it depending if it's positive or negative. Okay, so arithmetic is really nice. It's actually much nicer than what we did in 12.1 because these have to fit a very specific pattern. So right away, I notice for this one, if I want to determine if the following is arithmetic, if it is, find the common difference. Right away, I notice n plus 4. Doesn't that kind of look like x plus 4? And that would be y equals x plus 4. So that would be linear. So this is a line. I know it's not a line, but I'm saying it takes on that shape. So what I'm going to do is I'm going to assume it's arithmetic. Okay, and let me generate some terms. Okay, so if I want to generate the terms, the first term will be 1 plus 4. Right, comma, the next one will be 2 plus 4, the next one will be 3 plus 4, the next one will be 4 plus 4, oops, so on and so on, all the way up to n plus 4, which is right there, right? So now let's see what this creates. 5, 6, 7, 8, 9, all the way down to n plus 4. Okay, now think about this. How much is each term changing by, right? Each term is changing by 1. You're adding 1 to go from here to here, you add 1. To go from here to here, you add 1. To go from here to here, you add 1. So on and so on. So that's what tells me this is an arithmetic sequence. So yes, arithmetic. And the common difference, D, is equal to 1. You add 1 to get from one term to the next every time. So let me give you guys one. Let me have you guys try this one. So let's say we have this sequence C sub n, and it's equal to 6 minus 2n. And I want you to tell me if it's arithmetic. And so pause the video and try to find the common difference. So you guys are back, and again, it looks like a linear function. It's similar to it, so we're going to say it's probably arithmetic, but I'm going to write out some terms. So I'm going to plug in 1. So 6 minus 2 would be 4. Plug in 2. 6 minus 4 would be 2. Plug in 3. 6 minus 6 would be 0. Plug in 4. 6 minus 8 would be negative 2. Plug in 5. 6 minus 10 would be negative 4. We see a pattern, right? How much is it changing by from here to here, from here to here, from here to here? So all we have to do to find the common difference is you pick any two consecutive terms. So let's say this term and this term. And that's what they meant by this right here, by the way, you guys, when they said that D was worth A sub n minus A sub n minus 1. That means pick a term, and then the n minus 1 term, that's a fancy way of saying the term before it. If they had said n plus 1, that means the term after, n minus 1 means the term before. So I'm going to pick a term, let's say 2, and I'm going to subtract the term that came before it. Well, the term that came before was 4. So that means this is my A sub n minus my A sub n minus 1, a term and the term that came before. And then this would become negative 2. So negative 2 is my common difference. And now how do I know it's arithmetic? Well, that means that I should be able to take any two terms, this one and this one, and when I subtract them, I should get negative 2. Or this one and this one, and when I subtract them, I get negative 2. Whenever you subtract any two consecutive terms, one term minus the term that came before it, you should get the same common difference. Or you could just look, to go from here to here, I had to subtract 2. To go from here to here, I had to subtract 2, subtract 2, subtract 2, subtract 2. So I already know the next term will be negative 6 without even doing the math for it, okay? So this has a common difference of 2, and yes, arithmetic. And again, it's kind of easy to recognize because it looks like linear, okay? So let's look at something else. So now we have, I just want to kind of work with formulas for arithmetic. So formula, oops. So this is the general term of an arithmetic, the A sub n term for arithmetic. Okay, so we're going to say A sub n can be found by doing A sub 1 plus n minus 1 times D. So this is a formula you want to memorize or have in your notes. So if somebody asks you to find, so what they basically do with this is they say, find the nth term then find the 51st for the arithmetic sequence A sub 1 equals negative 2 and D equals 4. So basically what they do now is they can just give you pieces of information, and then you should be able to go back and build the nth term. So it's a lot easier to find the general term or the pattern because it's arithmetic. It already is, like, the pattern is already handed to you. It has to behave in a certain way. You know, all sequences have to behave in a certain way, but all those ways could be different depending on the sequence. All arithmetic sequences all have to depend in the, or behave in the same way. So they really can't hide from you. It's very straightforward. So we're going to use this formula, and we want to find the A sub n term. So I'm going to say A sub n is equal to negative 2 plus n minus 1 times the common difference of 4. So this will become negative 2 plus 4n minus 4. So I clean this up and I get A sub n is equal to 4n minus 6. So now I have my A sub n term, my general term or my nth term. So now I should be able to find any term I want. Well, they want the 51st term. So I just do A sub 51 is equal to 4 times 51 minus 6. So I just go on my calculator. It should be 204, but I'm just going to 4 times 51 minus 6, and I get 198. And I'm done. Okay, let me have you guys try one. So now what if I give you A sub 1 is equal to 0, and the common difference, D, is equal to 1/2. So you guys do the same thing I did, find the general term, and then find the 51st term for this problem. Okay, so hopefully you unpause the video now and we're ready to go. So we're going to do a sub n is equal to 0 plus n minus 1 times 1/2. So a sub n will equal 1/2 n minus 1/2. Okay, so that's not so bad. Or sometimes they like to write it as n over 2 minus 1 over 2, just because they, I honestly, I see it written like this actually more often than this. I think it's just an etiquette thing. I don't really think one way or the other really matters. In fact, I know one way or the other doesn't matter, but I see it written a lot more often like that when you're dealing with sequences and series. When you're dealing with lines, I see it written a lot more like that. So we know this is arithmetic. Once again, they already told us. That's why we're using the formula. Remember, this formula doesn't work for every sequence. This formula only works for arithmetic. So that's an important note I should put up here. This only works for this is specific to arithmetic, okay? So now we come over here. So now I know that my formula is a sub n equals n over 2 minus 1/2. And they want me to find a sub 51. So all I have to do is do 51 over 2 minus 1/2. So this would be 50 over 2, which would be 25. And I found my 25th term. I found my 51st term. That means if I wrote out the first 51st terms, you know, I'd write out 1, term 2, term 3, term 4. Once I hit 51, it'll be worth 25, okay? So it's really nice with arithmetic because we have this formula, we have everything that we can work with, okay? Now let's take a look at something a little bit harder, okay? So let's say find the term, let's say find the 80th term given the sequence -1, 1, 3, ... So this type of problem, they just give you the list of the numbers. They don't actually tell you the information ahead of time, and you have to figure everything out. So this is a really good test question. This is something that I'll probably ask you because it kind of relies on you to do a lot for this problem. So first thing we notice is that a sub 1 is equal to -1. And then we can find D by multiple ways, but normally finding the common difference is pretty straightforward. How do you go from -1 to 1? You add 2. How do you go from 1 to 3? You add 2. So I had to add 2, had to add 2. So I already know my common difference is 2. Okay, so now I can build a sub n is worth -1 plus n minus 1 times 2. So a sub n is worth -1 plus 2n minus 2. So a sub n is worth 2n minus 3. There is my a sub n, my nth term. I can find any term they ask for now. They want to know a sub 80. So I'm going to say the 80th term is worth 2 times 80 minus 3. So it'd be 160 minus 3, so I get 157. Boom, got it. No big deal, right? So sometimes giving you the sequence can make it harder, but with arithmetic, it's not so bad because we already have a formula for it. So now let's do find the nth term of an arithmetic sequence given the following. So now I'm going to tell you that the fourth term is 3 and the 20th term is 35. So the long way to do this would literally be to try to write out all the terms and try to write out 20 terms, but that's not what we want to do. What we want to do is we want to kind of fall back on our formula. So we're going to fall back on our formula that says a sub n, because they want us to find the general term, the nth term. A sub n equals a sub 1 plus n minus 1 times d. That's my formula for arithmetic, right? So they gave me some information. They told me that the fourth term, well, the fourth term would be a sub 4, is worth 3. So a sub 4 is a sub 1 plus 4 minus 1 times d, and they told me that it equals 3, right? Because I plugged in, so my n is 4, so that's n right there, right? I plugged that in right there. So they told me that. They also told me that a sub 20 is worth 35. So that means a sub 1 plus, let me see here, n minus 1, so this would be 20 minus 1 times d has to be 35. They told me this. So let me kind of set this up for you guys. This is a sub 1 plus 3d is equal to 3. This is a sub 1 plus 19d is equal to 35. Does this look familiar? This is a system of equations. A sub 1 plus 3d equals 3, and a sub 1 plus 19d is equal to 35. Now, we don't have to use matrices. We could, but I can see that if I just subtract these straight up, the a sub 1's cancel, and I get 22d is, oops, I'm not supposed to do that. That would be subtraction. This would be negative 16. So what I'm going to do is I'm going to subtract this whole thing. All right, so that would be the a sub 1's cancel. That would be negative 16d, and then this would be negative 32. I'm going to divide both sides by negative 16, negative 16. So now I have d equals 2. So I found my common difference. Okay, but if I know that d is worth 2, I can take 2 and plug it back into a sub 1 plus 3d is worth 3, because I now know that that's worth 2, right? So this becomes a sub 1 plus 6 equals 3, so a sub 1 equals negative 3. So now, wait a minute, if I have a sub 1 and I have d, I can build my formula. My formula says, remember, they want the nth term, so this is the nth term. A sub n is worth a sub 1, which would be negative 3 plus n minus 1 times 2, the common difference. Clean this up. Negative 3 plus 2n minus 2. So a sub n equals 2n minus 5. We found our fifth term. Okay, so remember, if you are asked, I'm sorry, we found our general term. If you are asked to find the general term of an arithmetic sequence, normally what you need to do is you need to find a sub 1, the first term, and you need to find the common difference. Once you have that, you can do anything you need. So this is a little bit harder problem. This would be one from the exam that's probably one of the hardest ones you'd get from 12.2, because they're basically giving you limited information and then making you build your own little miniature system of equations. Let me have you guys try one. So suppose I give you, so I said find the nth term of the arithmetic sequence given the following. So same problem as before. The fifth term is negative 2, and the 13th term is 30. Now there's other ways to do this, but there's kind of ways that you can just kind of count down in your head and do it. I want you guys to try to do it this way. So give this a shot, pause the video, do it the same as the previous problem, and let's see what happens. Okay, so hopefully you guys did the same thing as last time. A sub 5 is equal to a sub 1 plus n minus 1 times d, and we know that has to be negative 2. This one is a sub 13 equals a sub 1 plus n minus, oops, it's not n minus 1 because we actually know it's 5 minus 1, and this would be 13 minus 1 times d. So then this has to equal 30. So now a sub 1 plus 4d is equal to negative 2, and this is a sub 1 plus 12d is equal to 30. Let's write our system of equations. And now once again, I'm just going to subtract this whole bottom line, this whole bottom row. So these will cancel, and we'll be left with negative 8d equals negative 32, I believe. Yeah. So then divide by -8, divide by -8. So D is equal to 4. So the common difference is 4. So A sub 1 plus 12 times 4 is equal to 30. So A sub 1 is equal to 30 minus 48. So A sub 1 should be -18. So now we can do this. We can do A sub n equals -18 plus n minus 1 times 4. I believe that's minus 22. Yeah, sounds good. So, and if we did this, let's make sure this formula would give us -2, right? Because it says that the fifth term should be -2. So that means when I plug a 5 in, I better get -2. So if we plug 5 in here, A sub 5, this would be 4 times 5 minus 22 would be -2. So we're good. Let's do it for the other one just to make sure it makes sense. 13th term is 30. So that means when we do A sub 13, we better get 4 times 13 minus 22. So this would be what? 52 minus 22 equals 30, which is what they said right here. Okay, so it worked. We did it, right? So those are some of the harder ones you see for the exam. This last one is a formula for the sum of an arithmetic sequence. So finding the sum, okay? So what we have is we have this formula, S sub n is equal to n over 2 times A sub 1 plus A sub n, which makes sense that you need the first term and the last term of an arithmetic sequence, right? Because you need to know where it stops, or where it starts and where it stops. So suppose that I gave you 8 plus 11 plus 14 plus ... plus, oh, I don't like that one. Yeah, let's do this one. I don't like that one. Let's do 1 plus 3 plus 5 plus 7 plus all the way to 59, okay? So we have to figure out what term is the 59th term, right? Well, one thing we need to know that would help is the general term. And now understand what we're building. When you do 1, 3, 5, 7, 9, 10, 11, 13, so on, you're building the odds and you're starting at 1. In a previous video, we did a problem like this. This is 2n minus 1. That is the general term. So if I pick A sub 3, I plug 3 in, I get 2 times 3 is 6 minus 1, boom, is 5, just like we wanted. So that's the general term. So we need to find out when is 2n minus 1 equal to 59. That way we can figure out what term we're on. What is the 59th, or I'm sorry, what term would be 59? I have an idea what it is, but I'm just going to do the math. Plus 1, 2n equals 60, so n equals 30. So this sequence, or this summation, has 30 terms in it, okay? So then all we do is we go to our S sub n, and we're doing S sub 30. So this would be 30 over 2. A sub 1 is 1, plus A sub n is 59. So let's see what we get. We get 15 times 60, which would be, let's see here, 900? Let me just double check. Yeah, never mind, I know. Because 10 times 60 would be 600 plus half of 600, which would be 300, so we'd get 900. Yeah, so that's right, that's it. So that is how you can find the sum. So this is a formula that you're gonna need. Maybe I should go back and highlight some of these formulas. You definitely 100% need this formula for all time in arithmetic. Where did I put it? Right here. This is a big one, right? So anything with arithmetic, this is like your secret weapon. It's gonna make it nice and clean. And I want you guys to also notice that every arithmetic sequence, A sub n term that I'm building, they have all been linear, right? They look like lines, okay? So this is for a sum when you know the ending point. So what if I had, find the sum. Now, first of all, how do I know they're arithmetic? Well, look at how much it's changing by. 1 to 3 is plus 2, 3 to 5 is plus 2, 5 to 7 is plus 2, so on and so on and so on. So you can always distinguish an arithmetic pretty quickly, to be honest with you. So find the sum of the arithmetic, but even if they didn't tell me it's arithmetic, if it goes 5 plus 9 plus 13 plus so on and so on plus 49, right? Now I already know for this problem, without them even saying anything, I already know that D is worth 4 and A sub 1 is worth 5. I already know all of this, right? Just by looking at it, okay? So we're gonna do A sub n is equal to 5 plus n minus 1 times 4, the common difference. So we're gonna find what term we're on. Oh, we know it's worth 49, actually. So we know that it's actually the 49th term. We just have, I mean, the 49th value. We need to find out what term created that. So we got 49 is equal to 5 plus 4n minus 4. So 49 equals 4n plus 1 minus 1 minus 1. So 48 equals 4n divided by 4 divided by 4. So 12 equals n. So we're on the 12th term. So then when I want to find my sum, I do s sub 12, and it's 12 over 2. And then all I do is the first term, 5, plus the last term, 49. And let's see what we get. 6 times 55. Oh, 54, I'm sorry. And I believe that is 324. Yep. So we found the partial sum of this sequence when you add up all these terms. Okay, so that's kind of it for arithmetic. Arithmetic is really nice. It should be like one of your favorite things to deal with. Unfortunately, we don't see it a lot after this math course. You see geometric a lot, but not really arithmetic as much. But that's going to do it for this video, guys. Thanks for watching.